This problem has been asked in GATE 2015 session 2 and it is of 2 marks. GATE 2015 session 2, it has weightage of 2 marks, and this problem is related with analog and digital circuit subject. So what the problem says, in the flowing sequential circuit, the initial state before the first clock cycle of the circuit is Q1 Q0 is equal to 0 0. The state Q1 Q0 immediately after the 333 clock pulses, and the options are 00 01 10 11. So the given sequential circuit is shown over here, and if you want to have a deep knowledge about this JK flip-flop theory and concepts, so kindly refer this NPTEL course Basic Electronics by Professor Mahesh Patil, Department of Electrical Engineering, IIT Bombay. And I have also provided the YouTube link over here. So before we begin to solve this problem, let us have a quick recap about the JK flip-flop. In the SR flip-flop, we know that when both inputs S and R are 1, when both inputs S and R equal to 1, then the output of the flip-flop is indeterminate. So that issue we can resolve by using the JK flip-flop. Here in the similar to SR flip-flop, this JK flip-flop has also two inputs, and using the two inputs, the flip-flop can be set, reset, hold, that means memory, or toggled. But unlike the SR flip-flop, here in the JK flip-flop, when both inputs J and K are 1, then the output of the flip-flop toggles. The symbol of H triggered JK flip-flop and its truth table is shown over here. The symbol of JK flip-flop is shown over here, and the truth table for JK flip-flop is shown here. If the J and K equal to 0, then the output of JK flip-flop is to the memory, that is hold state. When when J equal to 0 and K is equal to 1, then the flip-flop is set, that flip-flop is reset, that is 0. And if J is 1, K is 0, then flip-flop is, and then the output is coming as 1, that is in set condition. And if both J and K are 1 and 1 respectively, then the output goes into the toggle condition, right? That means Q and bar. So that is the difference of SR and flip-flop, where in SR flip-flop, the output of flip-flop is indeterminate when both S and R equal to 1 1, while in the JK flip-flop, when both the output are 1 and 1, then this flip-flop output is in toggle condition. Now let us solve the problem. So here in this circuit, so let us first see the circuit. So here in the circuit we can see that the same clock pulse is given to both the flip-flops. Therefore we can say that it is synchronous counter. The same clock pulse is given to both the flip-flops. Therefore it is synchronous counter. Now let us make the table. So this first one is clock, and then second is flip-flop input, flip-flop inputs. So flip-flop inputs are J0 and K0. So here they are connected. So we will also write. So what is it is equivalent to J1 and K1. So from the figure we can see that J0 is connected to Q1 var. So we write it is equal to Q1 var, and K0 is connected to Q1, while J1 is connected to Q0 and K1 is connected to Q0 bar. All right. And the last column we make the output of flip-flop. We make the output of the counter, that is Q0 and Q1. So let us goes to the initial state. The initial state is given as Q1 is equal to 0 and Q0 is equal to 0. So the initial state is 0, 0. So when applying the first clock pulse, before applying the first clock pulse, it is in 0, 0, means Q0 is equal to 0 and Q1 is equal to 0, 0. Then we can write the flip-flop inputs. So J0 is Q1 bar, that is 1, and Q1 is 0, Q0 is 0, Q0 bar is 1. So if the flip-flop inputs are J equal to 1 and K0 is equal to 0, then flip-flop output will be that in set condition. So flip-flop output will be 1, and for the second flip-flop, if J1 is 0 and K1 is 1, then the output will be reset condition, that is 0. So based on this Q0, Q1, we can fill this table for the first clock pulse. So Q0 equal to 1. So Q1 bar is 0 and Q1 is 0, so it is 1. Now for the first flip-flop, if J0 is equal to 1, K0 is equal to 1, that is set condition. So output will be Q0 will be 1, and if for the second flip-flop, if J1 is 1, K1 is 0, that is set condition, the output of second flip-flop is also 1. Now based on this output, we will fill the table for the second clock pulse. So the output, so the if we fill the table, then it will be like this. Q0 is 1, so it is 0, Q1 is 1, it is 0. Now for the third clock pulse, if the inputs are like this, so we can say that if J0 is 1, K0 is 1, then the output will be reset condition, so it will be 0, and J1 is 1 and K1 is 0, then the output of second flip-flop will be set condition, so Q1 is 1. Now we will fill the table. So J0 equal to Q1 bar, that is 0, it is 1, and Q0 is 0, Q1 bar is 1. Now Based on this input to the flip-flop, we will get the output for fourth clock fourth clock pulse. So for the fourth clock pulse, if the inputs are like this, if the inputs of JK first JK flip flop 0 1, that means it is in reset condition, so output will be 0. And for the second flip flop, if the inputs are J is equal to 0, K is equal to 1, then that means reset condition, so it will be 0. Therefore, we can fill the table accordingly. So if Q is 0 is equal to 0, that means 0 and 1 it will be, and Q1 is equal to 0, that means fill here 0 and it will be 1. So from the table we can see that for every 4 cycles the output is repeated. So from table we get that for every, sorry, for every 4 for every 4 cycles the output is repeated. That means we have to divide it by 33. So dividing 333 by 4, we get 83.25. So that means at 332, so at 332 clock pulse, that is 88 cross 4 equal to 332. So it is not 83.25, it will be 88.25. So correct, sorry. So it is 83.25 and so 83 into 4 will be 332. So it is 83 cross 4 into 332. So at 332 clock pulse, the output will be just previous one. The output will be 0 and 0, that is Q1 and Q0. So at 333rd clock pulse, Q1 Q0 will be, so after this Q1 and Q0 we can say that it will be 1 0. Sorry, yeah, it will be 1 0. Sorry, it will be 0 1, because Q1 we have written earlier, so it is 0 1. So just take care of the things like we have in the problem it is asking about Q1 Q0, but here we have written Q0 first and Q1 in the second column. So just you have to take care. So if you are getting at 332 clock pulse, the output you are getting at 0 0, then after that you will get 1 0 as Q0 and 0 as Q1. So Q1 Q0 will be 0 1. So correct answer for this problem is B. That's all. Thank you.